So in this video, we are going to discuss about bandpass filter. So it is constructed by connecting first one low pass filter. The output of the low pass filter is connected to the high pass filter. Okay. There is a cascading of the input, the low pass filter and the high pass filter. So its frequency response will look like this. Okay. So this is nothing but FH. Okay. So till this one, it is nothing but a low pass filter, and this is your FL. Okay. So till this one, it is a high pass filter. Okay. So what is bandwidth? Bandwidth is nothing but the high frequency versus low frequency. That is bandwidth is equal to FH minus FL. So here this FH must be 10 times that of FL. So let us discuss about the circuit diagram of single stage bandpass filter. So I told you it's a cascading of so this is R1 and C2, okay, and this is C and R. So you can see it is moreover looking like a inverting amplifier. Okay. So here the at low frequency. Okay. So at low frequency, the XC2 value, right? The XC2 value is so large. Okay, because you know that XC2 is equal to 1 divided by 2 pi of FC2. Okay, so if for low frequency, the XC2 value is so large. Okay, so if that is the case, what will happen? So the circuit will change like this. Okay, it becomes open circuited. So if it is open circuited, I can connect R1 and C1. Okay, R1 and C1, then R2, R3, so the circuit look like this. Okay, so and we know that since it is an inverting amplifier, the A is equal to minus R2 divided by, right, minus R2 divided by, so this one is in series, right? So R1 minus J XC1. Okay, so if I take I can write it as R2 divided by root of R1, right, R1 square plus XC1 square. since we need to obtain the same gain for the low pass and high pass filter, right? So at low frequency, this will act as a high pass filter. Okay, it will act as a high pass filter. So here the XC value is less than that of R1's. Okay, so if that is the case, it becomes R2 divided by R1. Okay, so this is your yield. Okay, A is nothing but a voltage gain. That is at the frequency FH, right? At the frequency of FL, XC1 is equal to R1. Okay. So you will get 3 dB value, right? 3 dB value. Why? Because at this frequency you will get A is equal to 1 divided by root 2 you will get. And so this is, if I take 20 log of A, you will get minus 3 dB. Okay, minus 3 is the answer. So what will happen at high frequency? So at high frequency. So at high frequency, XC1 becomes so small. Therefore, it is short circuited. So if it is short circuited means my diagram will look like this, right? So if that is the case, you can see this this one is in parallel with this. So I can write it as what is AV now? A is equal to this one, parallel of this one. That is XC2 in parallel with R2 divided by minus value, right? Divided by R1. So I can write it as XC2 R2 divided by R2 plus XC2 divided by R1.
With being coming to go ahead.
So here if I take modulus value, I will get R2 by R1 into 1 divided by R2 plus XC2 plus 1. Okay, so what is XC2? XC2 is nothing but R2 divided by J omega C2 plus 1. So if I want to cancel this one, and I need to get the AS equal to R2 by R1. This is what I should get, because the gain is same for both the low pass and high pass. So this is your gain, right? This is your A. So that has to be R2 by R1. So if it has to be R2 by R1, so I can write XC2 divided by XC2 plus R2, right? So here the XC2 value is greater than R2. So if that is the case, I will get A is equal to R2 by R1. Okay, XC2, since XC2 is greater than R1, so I will get the answer as R2 by R.
there is a coming.
And you know that at the frequency FH, right? At FH, the XC2 value is equal to R2. Okay, so here there are two terms are there. One is Q factor. Okay, so what is Q factor means? It's just nothing but FR by bandwidth. So it is a figure of merit for a filter circuit. So you can see here it is nothing but a wide band, right? It is it's a wide band. Here the band pass filter is classified into two types. One is wide band pass filter, and another one is narrow band pass filter. Okay, so the Q values, if the Q value is less than 0.5, it is called as wide band pass filter. Otherwise, it is called as narrow band pass filter. So the narrow band means you will get the signal like this. Okay. So here you have the something which is called as FR. Okay. So if I take 3 dB value and if I take this one, so the bandwidth look like this. Okay. So what is the value of resonant frequency is root of FH and L.